Everyone, and welcome to Groundwater Talk Live. We have a special guest today, Stuart Smith of Groundwater Science, who's a renowned groundwater scientist that's been in the business for a long time. He has a wealth of knowledge. As a matter of fact, I want to point out this is a book he co-authored here with his partner, and you can see that that I have a lot of tags on here because I've referenced this book a lot, and he and I have exchanged information over the years, and just a wealth of knowledge. We're going to talk today mostly about well rehab and maintenance, and kind of get into the esoterics of that. But I want to talk a little bit more about his work in Tanzania too, and some other topics as well. So without further ado, let me bring Stuart on here. Make sure everything is working as planned here. All right. There we go. Stuart, good
Hello.
afternoon or good morning. I guess it's still
Good
morning.
morning.
How are you doing today?
I'm doing just fine. I
Great.
assume we're on, right?
Yes, we are. So
Okay. All
volume
right.
seems to be
New.
working okay. Um, can you give us a little, before we dive into the topic of the day, can you give us a little bit of your background? I kind of, floated a little bit of information there, but you certainly have been in the business for quite a while and have a lot of experience in wells, and like I say, literally wrote one of the books on the topic, and it's a well worn um, product of member of my library.
That's good to see. Yeah.
Yeah.
Well, yeah. If you've been in something for a while, usually you've done something. You hope, but I got started in the groundwater industry per se about 1979 when I joined the staff of the what's now the National Groundwater Association. It was National Waterwell Association back then, and after a year and a half of deciding didn't want to be a secondary school teacher anymore, that was a welcome break. That was in the Jay Lear era. Uh, the legendary Kathy Butcher was my boss during that time, and we've collaborated since. And at the time, a lot of of calls would come in and so on about iron bacteria and about corrosion and subjects of that nature. And being that I was the only person on staff at the time with anything like a biology degree, I was assigned those contacts, and then that also uh, ran back to I pulled and set a lot of pumps with my dad when I was a teenager and in college with that red and black stuff on my hands, and so um, I found out down the road was a professor at Ohio State that was, internationally known in iron and sulfur corrosion, and sort of took off from there. We did some research, collaborated with people internationally, uh, started to redo um, the thinking about well rehabilitation and the causes of problems. And I've been in private practice since 1986 or so, give or take, and um, and that also involves being country hydrogeologist in Ohio and surrounding areas as well, just in more conventional things.
Awesome. And you do some work in Tanzania now too. So you have a separate company that operates over there. I see a lot
Yes.
of posts on LinkedIn about your activities over there, and I find it interesting. I one time looked at getting involved in that and I know a lot of people that are, and I just never took that step. So I admire you for doing that. So tell us a little bit about that.
Well, that's an interesting thing. It all started with I'm a Lutheran Christian, and our synod in Northwest Ohio was connected with the Dodoma Diocese in central Tanzania, and so some one thing led to another, and I visited over there, and you become, and being it's kind of a high dry place, sort of a like New Mexico, you know, water becomes a topic, of course, and then one thing led to another. I started advising informally, and also with a committee of of Catholics over here in the Youngstown diocese where I live now, and just seemed it seems like it was a sort of a destiny or purpose, you know, for these connections. We started. My partner there, Naftal Mondi, and I started also trying to manage projects formally, you know, for people. So, you know, make sure the money went where it got to, make sure the quality was done where it went. And finally, he told me, you know, the only way that we're going to get this done is if we have our own equipment. So, you know, between 2018 and the present, we've built a a full scale water well construction company with two drilling rigs and associated equipment and all the pumping and everything like that. So 20 people. It's a bigger deal than my domestic company.
Well, you're doing some good over there, and interesting. You're working through the churches. God has a purpose for a lot of things.
Yeah,
It manifests itself in different ways. So I appreciate you doing that. So,
I
uh,
find that comes in the form of being shoved in the back to do something. So more than anything else,
yeah, God
not
does have His
necessarily
plans for us
willing.
to work in mysterious ways, right?
I avoided being a water well contractor until into my 60s. You know, I know how expensive and how much trauma that goes along with that. So
Yeah.
yeah, but now
It's a
here we
tough
are.
business. Yeah, I do admire water well drillers because it's a tough business, and there's not a lot in this country anyway. There's not a lot of young people coming in the business. I don't know what we're going to do with, as that industry shrinks down, but it's like so many industries, that young people aren't doing it. So it's a challenge.
It may be that, particularly on the driller end of things, that it becomes a an entry point for immigrants. You know, they're the world over, and particularly in the global South, there are dedicated drillers. This is probably like the farm boy thing, you know, in our generation. You know, you're willing to work hard and be out there all day and all night, and that might you can't have any of our people, but you know that might be something like that that's part of the equation.
That might be the answer. So it could be. It could be because as people come to this country, they're hungry, they're hardworking, and
Mm-hmm.
so get them into the trades. So whether it's drilling or these other trades, not a bad way to go actually.
Oh
All
yeah,
right, so
yeah.
so let's kind of dive in a little bit, and I'll put the focus more on you here since you're the guest, and talk a little bit about rehabilitation, and I'll just kind of set the stage here. Is there's a couple things that I typically get asked is when is the right time to do rehabilitation, and I see so many wells that people have gone for 40 or 50 years and never rehabbed the well. And then,
Yeah.
you got some
Problem number
wells.
one.
Yeah. And then you got some wells out there that plug up after 10 years. And I always say wells are like people. They have individual characters to them.
Yes.
And every well is different. You can have wells that are 100 feet apart and they'll have totally different chemistry and microbiology going on. And so people need to understand that we need to kind of assess things as we go along, and just wanted to kind of look at that and then talk a little bit about the rehab process, that it's really important to understand the difference between if you're rehabbing for mineral incrustations as opposed to uh, biofilm different chemistry and stuff and different approaches for the most part. And then we can kind of get into what does it take then to maintain that well after you've rehabbed it, to kind of stretch out the time in between rehabs. So maybe we can just start about, you know, how do you how do you assess when it's time to do well rehab? I like to do videos, and I recommend folks do videos at least every few years. But what are your thoughts on that? People hate to pull the pump and all that stuff to get it done, but I think it's really a great component, and the testing we can do. So let me let you launch in on that and wax poetic on your thoughts on the topic, because I know you have extensive knowledge there, and what's your best practical advice on that?
Well, one thing to do is as much as possible from the very beginning. If particularly for an operator or something like that, maybe backing up a little bit is dealing with what scale we're working at. And there's several problems with um, working at a municipal and irrigation scale like we do. More so is in some ways easier because at least there's a budget. There's also the problem of the many millions of domestic water wells here in North America, for example, and also then the global problem, so it's a matter of resources. But I'd say one place to start, if at all possible, is at the very beginning and understanding what you have to deal with when you're starting. You may have a history from old water wells. Old water wells in the same location are likely to, this like geologic and biological processes of any kind. They're going to be about like what's going to happen to the new well is about like what happened to the old well, give or take. That fractures are different or units are different. So you
So
can expect that, and then
establishing
find
a
out what the water
baseline, then
quality is. Yeah,
establishing a baseline.
establishing a baseline. This is something we press real hard with engineers, particularly at the material design end of things. Is that okay? This water here is this particular place is going to be guaranteed it's going to clog. So let's be planning on that. Or maybe this isn't so bad. Then once it's constructed and in place, do some assessment. There's a range of biological and chemical tests that can go along with anything that can be done. They're not always part of the standard EPA testing, but we have them now. I was there at the beginning of a lot of it. I was there before it was available, when we had to make up all the stuff ourselves. Now we have prepackaged tests. We have instruments you can take into the field. It can be done if people would just do it. And then once you understand that you've got something like, say, you're going to have iron clogging, you're going to have manganese clogging, and or sulfur, then you can plan accordingly. Obviously, video from the very beginning. Video when the well is in, so you have a baseline. Video when you change pumps, primarily. At whatever interval that is. Municipal systems should probably pull it by 5 years and every 5 years and take a look at it anyway, or make it easier for a small camera to go in or something. Whatever's possible, and then try to get a hold of it before you see your specific capacities go down, particularly in sand and gravel. You're going to fill up with a mass of iron or manganese, for example, that a lot sooner than you actually see the specific capacity signal go down. And when you do testing, do proper step tests and analyze those, analyze for the well loss, analyze for the aquifer loss, and you can see where the problem is the situation, and you can plan the rehab accordingly. So,
And
those are
maybe
that's
just
part of it.
explain real quick what specific capacity is for the people. I talk about it a lot, but there may be people watching that don't know. It's a really easy measure to do, by the way. So
Yeah, specific capacity is the flow is the flow rate per unit drawdown. And here in the United States, that's typically gallons per minute per foot of drawdown. But internationally, it's going to be whatever your convenient units of flow rate are per meter. That's the rest of the world. And so numbers don't always look the same when you see them on a sheet unless you convert it. That's related to the transmissivity that the well sees. So you have a transmissivity of the aquifer, but as transmissivity changes around the hydraulic conductivity time length around the well itself, then you begin to see the specific capacity change.
as it'll go down as it plugs up. So
Yeah, it'll
by
go down as it plugs up, and also it plugs differentially. That's why I mean, if you do the step test, you can analyze it. You can figure out what's happening due to turbulent loss around the screen and what's happening due to plugging further out into formation. Yep.
right. It can be a little deceptive too, because sometimes I've seen wells are pumping along. Generally, the water finds its way in there, and we've taken videos
Yep.
of wells that you really wonder how there's any water getting in there at all, and you've probably seen
It,
them too. And all
oh
of a
yeah.
sudden, that last little pathway just plugs up, and all of a sudden you have no water. So it's important to watch the trends. I think is what we do with
It's really
specific.
important to watch. It's really important to watch the trends, watch specific capacity. You can see a trend line. Typically, it's going to be linear over time. You can see that it's going to drop where it's going to drop to. You can. I have charts. I don't happen to have one up here right now, but the shows specific capacity over time. You can see where they've rehabbed it. You can see maybe that the well was underdeveloped at the very beginning, never developed properly, and then maybe a cleaning done at year 7 gets it up to its potential, then it declines. Those are really important, and it's something that anybody can do. It doesn't have to be at a municipal water system. If you're managing a domestic water well, it's something you can definitely do on your own. Just a little bit of uh, of measurement and watching things and keeping track of it. The domestic water wells, that's kind of the hardest part because people just expect to turn the water on and go, like if they live in a city or something. But actually, you're a water operator if you have a domestic well, and everything that happens to municipal wells is going to happen to domestic wells. Only they're smaller and they're more difficult to clean, and typically, not always, but typically more fragile than a municipal water well is going to be. So you can't go in there and you know really hit it quite as hard with the cleaning, for example, without busting a hole in the plastic casing or something like that. So,
Yeah,
so it's
we've gone a lot to plastic casings, for domestic wells, and yeah, they are more fragile. They're certainly cheaper, but that cheapness comes with a price too.
yeah. But everybody is everybody is used to some kind of preventive maintenance. They have vehicles in the driveway and they've got teeth in their heads. And both of them we have preventive maintenance mindset on that. You go to the dentist and get a checkup and get a cleaning. You take your truck in and every 5,000 miles and get it looked at. But the well is the same thing. It doesn't just go on and on. And it's not just domestic people. I ran into this internationally where you had to some engineers we worked with in one place were terribly shocked that yes, you're going to have to be in maintaining these water wells for the rest of their operating lives. You know, they figured they would just put the pumps in and go back to where they came from. So
Yeah, it's part of the life cycle costs. A few months ago, I had Marvin Glotfelty on the show, and that's one of his concepts is life cycle costs,
great.
and you just gotta
That's very
you gotta
important.
build the
Yeah.
cost. Yeah, the cost of the well maintenance and the rehab in there, and sometimes it depends. A little bit more expensive well up front can reduce the back end maintenance, and these are all things you got to kind of work. I mean, that's more of a factor when you're talking municipal type wells as opposed to domestic wells, but it does make a difference as part of the whole picture is sometimes our American attitude of the low cost bidder is not the
Mhm.
best way to go. So
Yeah,
um,
best. Yeah, best. We want to go toward best. Like we.
yes,
Um, is sometimes again the things things translate. We know that uh, in terms of vehicles, we know that some vehicles are going to have a better uh, operational life than other vehicles that maybe cost less. We've all had experience with this. I've had bitter experience with this and good as well as good experience. And it's the same thing with wells. Spend some more to on the quality at the beginning. Let the well driller develop the well until they're properly done. You get ahead of the game, and the life cycle cost over 10 or 20 years is going to be more more favorable to you. But it's getting people. It's like anything else, getting people to think long term. Whatever the subject is. Lifespan or your water well or whatever it is. Lots of people think short term. They're not thinking long term.
and when it comes to wells, it used to be 40, yeah. The EPA still uses 40 years as the life of a water well, but we're really designing wells nowadays for 70, 80-year lifespans.
Right.
And you
That's
know,
the idea. Yeah.
yeah,
Uh,
it's a big deal. So, I mean, they're going to outlast us.
yeah.
Sure.
I if there are if there are water treatment plant operators on here listening, one thing I would suggest is to educate yourself about water wells and how they can be better constructed and better operated and so on, so that you aren't entirely relying on your water well contractor who may come or go depending on your bidding processes and so on. Then you can understand that we've had some recent experience where uh, operational leaders that did not know anything about groundwater made some poor decisions about the wells they installed. And, they could have been better. Now these wells have had to be replaced, within a few years of their construction by ones that are now designed and engineered for the purpose instead of uh, the way the first ones were. And these are things. This that cost them a lot of money. It put into jeopardy a $30 million project, and it that could have could have been a problem. So, and if there's anybody in the international donor community and so on also listening, is can we get past the slotted PVC casing now? Worldwide, globally, is these wells put in for village water supplies are, the screened area is the 1 millimeter slotted PVC screen with gravel pack around the outside. And that is incredibly inefficient, and it's going to clog. And we run into this all the time. That's one of my long-term things in Tanzania is, gentlemen, ladies, can we can we put in proper well screens now? I know it's going to cost you more, but can we do this? So, and it's worse when you put in a better well casing, that's you know consistent with our SDR 17 and SDR 21. Is the slots are actually the slots are longer, of course, through the plastic, and they clog up.
It all the well design, the well construction, the rehab, the maintenance all
Yeah,
ties together, and it
the
is,
circle
you know,
circle of life.
exactly. And a lot of people don't make that connection, but it really is important. So all that upfront planning can really help with the cleaning and maintenance down the road. So, and I do want to say that if anybody out there has any questions, to pop them in
Yeah.
the chat, and I'll bring them up here. So I will say, Stuart, that we sometimes get people watching live. Most of the questions come later, so we'll
Yeah.
we'll get at the end, your contact information too, and I'll post it on the video. So let's
Yeah.
move
I'm
on a
good.
little.
I'm good for that. Yeah.
Okay, yeah. Um, let's move on a little bit to the actual rehab process and really, assessing the well, determining what the problem is, and then designing a well rehab program for that particular well. Now, I know there are rehab contractors out there, and some prominent ones that have these one size fits all solutions that I am not a fan of. I think the individual problems in the wells need to be diagnosed, and there needs to be a specific process for that particular well. Even if it's adjusting the amount of acid or whatever that is. And I just wanted to get your take on that, and then how we approach that particular problem. So
That's that's something that's it's almost like maybe we need to write a book about that. It is a is how the well rehab has evolved. I'd say over the last generation. It's it's getting to be the point now. We think about what's 20 years ago, and I realize what 20 years ago is turn of the century. And whereas I'm thinking back into the 80s and 90s, 1980s and 90s, that is, and where there was a while there. Of course, if you go way back, like say before the Second World War, basically what you had to work with was mechanical rehabilitation, primarily the cable tool drilling rig, and it was mechanically effective. Uh, when you come into about World War II, because of chemistry, then suddenly you had a lot of chlorine, and you had a lot of hydrochloric acid around, and people figured out pretty quickly that you could clean wells with that. It works pretty good. It has its downsides, as we know, but it's pretty good with that. And then there's the American viewpoint on a lot of things: is if some of that is good, more is better. And so then, by the time I came into the sector, it was we pour barrels of chlorine and barrels of acid down wells, and whether it works or not. Part of it, like uh, a lot of people, other people working in the industry have figured out that you can use these chemicals, but it's better to use them in a targeted way. Where manage the pH that manage the pH of the solution so that the chlorine works better. Use just the amount necessary, and so that you don't overwhelm the problem with another problem. The other thing is figuring out that other types of chemistry come alongside these and actually work better. And part of it, you see some in the industry now, and I'm on the losing end of that because of I don't have as big a platform as some other people, but there's divergent opinions on what chemistry should you use for biofouling, for example. Um, and then what gets lost in the discussion is still the need for uh, mechanical force. You don't just put chemistry down there and expect it to do something. You have to move it around. And so now we have the cable tow rig has been with us all along, and it's still very, very effective in many situations, except many people don't know how to do that anymore. And so it's become a lost art. But fortunately, there are some improved tools that have come online, to even, various kinds of high pressure jetting. We have some prominently here in the United States, and other companies prominently in Germany that also have contractors using their equipment here in the States, here in North America. And that's, getting the force and the chemistry where it needs to be is that. And that's why, we like to do specifications. Like, for example, our company, we do detailed specifications on well cleaning for our municipal clients. This is what you do. Test it up front, do the step testing, do the video up front. Here's what the cleaning is going to be. Here's how we're going to evaluate that. And then, the post, the post cleaning evaluation.
Excellent point. Yeah,
So,
excellent. Yeah.
so I don't use the biological testing as much as I used to, because I'm more likely I just know it when I see it. But, maybe others trying to understand and replicate this should, you become also acquainted with testing, like the BART tests and so on uh, that get in there, along with the chemistry. You have to know the geochemistry to go along with that, is to understand what is happening. Not everything is iron bacteria. Yeah. So.
Yeah. There are the slime formers too. Well, and things like too, like hardness and stuff can affect how,
Right. Yep.
your acids and things. So you may have to increase the percentage and dealing with those types of things. So
Yeah.
those are kind of some of
Some
the
of
subtle
those.
things.
Yeah. What's important thing right there is some of the organic acids, which are very effective in some waters, when they get into a high hardness, high TDS, high hardness, high alkalinity situation, can actually form solids and counteract, what, add to the problem, not solve the problem. So, there's different chemistries for, say, a granite water in North Carolina versus you know, something here in the Midwest with high hardness and high alkalinity.
Exactly. So, yeah, so some of those tests ahead of time, I think, are good for really dialing in, what you need specifically, instead of just, have an understanding of your chemistry and how it's going to affect your acids and use the appropriate amount, mix the appropriate amount up
Mm-hmm.
instead of having to do it in the field and experiment. That gets costly and usually people don't like their wells to be down for any longer than they absolutely have to. So get in,
Oh no.
get it done.
And therein is a problem, say uh, with domestic wells, for example. People generally have one water well and uh, they don't have any margin. They don't have any way to. They typically don't have a tank overhead like you do in a village in Africa. That's at least you can store water for a day. Um, Laundry is piling up, and this guy is out here messing with my well. Uh, Municipal situations, you got 3, 4, 5, 17 wells, so you've got some way to work around that. An interesting thing that happened, I didn't necessarily see it coming early on, was how well rehabilitation chemistry uh, and it's uh, and the marketing of it and everything like that, how that developed in the groundwater industry that was differently than I thought. Back in the '90s, we were we were selecting chemistry off the dock, and we were making our blends in the tanks, based on chemistry or whatever. And then, of course, very, very smart and clever people figured out that you could put blends in a jug and call it some name, Easy Clean or something, and you can sell it to the well drillers and you put a chart on the back with pictures that says like IKEA, it says like do this, you know,
Yeah.
uh, and that's kind of the way it's developed since then. It's not necessarily bad, but it also people get fixed on. Well, Easy Clean really helped me out that one time, so you should use it too. So it's not necessarily a systematic way of going at it. Uh,
Well, and
and
you
also,
touched, yeah. Oh, go ahead. Yeah.
I was going to say, also as a hydrogeologist working with well contractors and enforcing specifications, it's another version of the geologist driller thing, that we all joke about. So,
Yeah.
like
Well,
when you complain about, don't, why are you swinging those barrels of hydrochloric acid with the crane up there? So it's, and where is your PPE? Well, they didn't send it along, and it's an hour back to the office. Do I have to go back and get it? Yeah. So
yeah, that's interesting. Well, I always tell the drillers, I said, I won't pretend to be a driller if you don't pretend to be a geologist, and
yeah,
but it's really a working relationship that we have,
it
so
is.
we got to
Yeah.
work together, yeah, because
Oh
drillers have
yeah.
a lot of knowledge and we don't have too,
They
so
do. Yeah,
yeah,
they certainly do. And they have a lot at risk. It's me and my pickup truck and my instruments and a home office, versus, that yard full of $1 million stuff that they've got there. That's to be respected. For
exactly.
any geologists that are out there that don't have proper respect for well contractors.
Yeah. I'm always amazed at the drillers. They can just put their hand on the drill, and know
Yep.
exactly what they're getting down at the bit, and can kind of tell
Mm-hmm.
you. So you know, I use that a lot in the field. Um, so let's talk a little bit about chlorine and its role in well rehab. I talk to a lot of people that think you can just and we'll talk about it in well maintenance too, but as far as the actual cleaning is that there's a lot of bad information out there that says, well, if you got iron bacteria, just use chlorine, and you know that 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 myth persists out there, and I keep
Yep.
telling people why that is, and maybe you can expound on that a little bit too. That chlorine is great for maintaining your well, but as for getting rid of the biofilm, not so much.
Yeah, chlorine, and by the way, this dependence on chlorine is kind of an American thing. The Europeans think we're nuts. They use they're more likely to use peroxide or something like that. But if you actually have an iron or manganese is more difficult. Because uh, or you actually have a clog based on these that's got a biological basis. Your problem is the clog more so than killing bacteria. You're not, first of all, you're not going to kill very many, even with chlorine. But what you need to do is you need to take that clog apart with the chemistry, and that's where the acids and the polymers come in. The chlorine is more or less the cleanup phase. That's where you repress the amount of bacteria that are present, and then also you provide a safety for whatever you might have introduced from the surface, from unsanitary conditions. And then so that's the role of chemistry. So use again, alluding back to the earlier thing where if a gallon of chlorine is good, some people think that, well, let's just put a barrel in and really do it. We're that's actually counterproductive because we're using hypochlorites mostly, and and when you and that's a very, very alkaline product. And so what you need to do, what's the kill part of the hyper, hyper sodium hypochlorite or calcium hypochlorite is actually the hypochlorous acid part of it. So you need to get the pH down where it belongs. A lot of charts on that. There's also buffers that can be used for that purpose. But if you're using chlorine in wells, you need to find out how to use it. And this is difficult. I can tell you that my uh, my mother-in-law, God rest her soul, uh, had this groundwater biologist in her family, and she would still just pour a jug of chlorine down her well every so often and not listen to me about that. Like, maybe we don't need to do it that way. So you can extrapolate that outward. Like, what does this guy know? We'll put the chlorine jug in it. So chlorine is more of a cleanup and finishing step. If anything, it's not a primary way of taking care of those. If you have a sanitation problem, perhaps it can be used for that. If you have a total coliform uh, positives that are above levels, try it with that. But then you also have to go back and figure out where that came from. If it comes right back, you've got to sort it out. The thing with clogs, like iron or whatever it is that it you clean it up back, a few centimeters into the formation, and that's as far as you're going. And then when you go away, they come back. So that's where the maintenance aspect of it is come in. You don't, you're not sterilizing. First of all, you're not sterilizing anything. So let's get rid of that word. But you're certainly not sterilizing an aquifer.
Exactly. Not for long anyway, but and
Yeah.
people don't understand, and I've seen a lot of well rehab efforts, I guess, or you call it well rehab. I put that in quote marks, is where they run a brush down and then
Mm.
they do a video and they've got the inside of the well all shinied up,
Yep.
but
Yep.
it's like an iceberg. The main problem
Yep.
is outside the well through the screens and outside the well, and they've never touched it. So you're back a year later, you're back to clogging again because you didn't really address the problem.
Yeah. Brushes are good, but as far as they go, but you have to get it. You have to get out in the formation and loosen up and break that up and open things up for a while. And like you talked about earlier, you can get a lot of water through a small screen section. It's incredibly inefficient, but you can still do that. And some types of cleaning will do what I call is they open a flap, but then it closes back down again. That's a pattern where you've cleaned it, and then 6 months later, your specific capacity is spiraling downward again. You just haven't really addressed the whole situation.
Right. And I go back to the excellent points you made on specking out the whole well rehab process is that's really what's going to get you the most efficient well rehab that's going to, knock things back for the longest period of time possible. And people need to understand too that well rehab, you're going to keep doing it, and it's just a matter of how fast things clog back up again. And the expectation is you're not going to do it one time and you're done forever. it's
No,
it's going to come back,
no,
and you need to
it's
keep monitoring that
it's
specific capacity. And
it's part of your life now.
yeah,
Once it starts, it's part of
yeah,
it. It's part of your long term plan.
yeah. So let's go to, and we can kind of wrap it up, with this, because we've been kind of at this for about 45 minutes now. And so once you've got your well rehabbed and and in pretty good shape, restore the specific capacity back to pretty much where you wanted it to be. How do we look at, is there, and this is a question I get a lot, and it's a fair question, is that how do I maintain that well? Is there anything I can do? Dump that chlorine down there and circulate it with a pump or whatever to maintain things to not have to do well rehab again in a couple of years. Assuming you've done a good rehab job, how do we then maintain that well going forward? And I think that's kind of the frontier, and
Yeah.
and maybe there's some well designed stuff even we can look at down the road too. But just
Oh
get
yeah,
your thoughts on that.
and on the more valuable wells, if you can set them up so that you can test them without having to, bring a crane in, pull your pump, all that. If you can set it, we've just done that on one where we had them set up so that somebody could just bolt a valve and a hose on it and start it up to clean it. And that's right there is if you can watch your pumping water, know your flow rate, watch your pumping water levels, keep track of that, look for trends. If you can do do testing periodically to see what how it's performing, and you can start to see when it starts to trail off a little. You're also, you know, there is the biological and the chemical testing. You can see that if you're starting to get bursts of iron or bursts of manganese, that's biological typically. Uh, Things like that. You alluded to our book, which is kind of uh, it's kind of sort of out of print. They'll print one for you if you ask them or if you pay for them. But they have a lot of step by step in there, and hopefully we can bring that back out and do that again. There's step by step processes. This is how you do it. So yeah, sustainable wells. There it is. I'd like to
Yeah,
see that all that
and you can see
dog earring on that.
all my tags in
Yeah,
there.
yeah.
It's
So
like I say, I use it a lot. So
yeah, that's we need to get that back out again. But anyway, so those are things you can do. Probably, I hear it a lot. That's not wrong. Is uh, getting contractors getting their municipal customers, say, or irrigation customers on a 3-year or 5-year and cleaning. That's just a good plan. You just budget. You just do that every 5 years. You budget this amount of money and do that. And that's something you can establish once you have your trends and you know what you're dealing with. For example, just from our experience, we can tell someone you're going to be cleaning this well in 3 years, or you're going to be cleaning this in 7 years, and I got to say, I'm very seldom wrong. Just because you know it when you see it. So
yeah, the trends don't lie, and
but
y-
they don't listen. So.
yeah, well, that's true.
My
And
world's
what's
told
yeah, I know.
right.
But what's interesting to
And
me
clearly,
is a lot of these water systems collect this data, and then they look at it and they throw it in a file, and they never look at it again.
yeah,
And
yeah,
that's
they're busy. They've got something else blew up. They just don't get
right,
to it. I understand.
right.
Yeah.
Yeah, but it's valuable data that they get somebody
Mm.
to put it in a spreadsheet and graph it out. Then you can sit down and just look at it once or twice a
Yeah.
year, and
Yeah.
and you got that information right there. But it's amazing how many people don't have that. You know, we probably have similar experiences with that. It's kind of like you got this
Oh
data,
yeah.
use it.
Yeah. I mean, we're always that's one place we start usually as we go in with a new clientele. We will mine what they have and try to make sense of it, give it a start. What's the specific capacities, histories, what are the things that, what do the old pictures tell you, you know, things like that. So it's forensic, in a way,
Right.
kind
Right.
of, and just to make uh, get the international view of it out there is that so many there's with the with the push to get universal water supply going, there's a lot of a lot of stuff going in all over the world, and I don't necessarily see these being planned in a way um, that gets them to the long term. For example, with a lot of these, they put in hand pump wells in the village, and they and 30 to 50% of them are not functional within a year, and they and then that just discourages people. What if you there's a whole thing of stop the rot with hand pumps. There's a whole thing. If look it up internationally, it's quite interesting. But just that, why don't we just stop using black iron pipe or galvanized pipe in corrosive groundwater? Yeah, So uh, I'd say stop using hand pumps, period, and put in proper pumps so grandma doesn't have to pump that handle after she's walked a kilometer for that water. But anyway, that's the next thing is let's design this stuff so that it has some longevity to it.
All right. Well, probably getting down to the end here. Any final words, and then let people know how they can get a hold of you. I know you're active on LinkedIn, so that's a great place. But and I'll post your contact information in the show notes too. So
Yeah, just I would encourage you to uh, what worked for me was integrating several bodies of experience. Like I said, going back to pulling wells with my dad, then the biology and the chemistry and the hydrogeology. Is so sometimes you want to get out of your silos and look at different uh, information that's going to help you out. For example, if you got excessive nitrate in your groundwater, maybe don't look at the geochemistry so much. Maybe look at, are the water wells in your area actually have proper casing seals around the outside? There's we run into that in our Tanzania work, for example, and uh, also just encouraging people, encouraging younger people to get into this. I see a lot of gray hairs in out in the field where we're working, even the geophysics people. So it's water. It's going to be only become more and more important globally. So it's get involved in that. So I don't know.
all right.
Been a good it's kept me interested for the most of the things times. Collaborate with other people. My business partner Alan Komeski is, it's really a superb well hydraulics guy, and it's I learned a lot from him. That's how you do it.
Yeah, I agree. Those collaborative arrangements are great, and especially for us small guys. you know,
Yeah, yeah.
Tapping into other people's expertise. All right,
That's
so
the other
how do
thing is stay small because then they don't put you in a corner office and keep you under glass. That's been a blessing of my life as still get out there and stand around, watch people do work. But
I, I agree. I have found I have more fun when I can just kind of, work on mainly what I want, and I
yeah,
say I'm getting old and crotchety, and I only work on stuff I want to. But but I think that benefits people in the long run when we niche down and not try to do everything. So, how do people get a
yeah.
hold of you if they want to contact you about your work in Tanzania, your work here in the U.S. and you're in Ohio, so
Yeah, well, the contact information I'm sure you'll put up. That's the way to do it. Probably email is better because I can look at it and think about it for a second. I have a mobile number that I use globally. We have websites, groundwaterscience.com and groundwatertanzania.com, and those are points of contact. I'm on LinkedIn, uh, Twitter or X or whatever they call it, and as groundwater science. I spend too much time on this stuff.
Yeah. But it gets the word out there, and I will say that your
Mhm.
posts on LinkedIn especially are always great. So folks should follow you there, if nothing else.
Sure.
So
Yeah.
all right. Well, Stuart, it's been very informative, and I appreciate your time. It ran longer than I thought it would, but it was an interesting topic and a lot of good information there for folks. So I appreciate it. And you and I talk fairly regularly, so I
Mm.
appreciate you coming on, and
Yeah.
hopefully people got a lot of value out of this. So.
Yeah. Hopefully, like I said, we can talk all day on this stuff. So uh, this is a sampler.
Yeah, we'll probably have to do another show to cover, things like well development or well seals and
Yeah.
stuff too. So that's always a good
Oh
topic
yeah.
as well. All right. Well, thanks so much, and I appreciate you coming on.
All right.
Let me wrap that up here. So there we go. All right. So thanks everybody for tuning in. And if you have any questions, I will post Stuart's contact information in the show notes. So you have that information. But like I say, he is active on LinkedIn, which is, where I communicate with him a lot. If you have any questions for me, you'd like to be a guest on the show, there's my email address there. And I appreciate it. And we do this every Thursday at 11 a.m. Central. So we will see you next week.